Welcome back to Panga's Shed. This is a very nice BF gas Barra. Over there is a broken XR6 Turbo. This engine in that car. Let's do it. I have a BA XR6 Turbo in manual, skinny rod life. It had a catastrophic engine failure, and I bought the car as is. This is the engine that's going to be replacing the skinny rod first series turbo block. It's a very nice gas engine out of the BF, so it should have the stronger rods. It's only had 160,000 Ks on it, and it's in really good condition. The timing chain situation is all pretty much brand new. It looks very clean in here, even though it is a gas engine. They run clean anyway. The cams are hardly damaged. It'll be the perfect engine to put into that car. But not all is lost with the other block. It did have some crow valve springs. I had already pulled them off that engine, and we're going to be installing them into this. I'm not going to do head studs, and I'm not going to do gasket. With the power level I'm chasing, hopefully around a 270, 280, maybe 300 rear wheel kilowatt, I shouldn't need to do the head studs or the gasket. I guess the weakest link now is going to be that 5-speed gearbox. So anyway, I just want to get the car back on the road. So I'll be installing these valve springs to prevent any valve float. Also, because it is manual, it's common that the gears on the oil pump do shatter and stuff like that when you rev them up high and limiter bash, which I won't be doing. But I have taken a liberty and bought a set of gears, billet gears, and a backing plate. I've already taken the old pump apart, so I'll swap them over as well. Install it with a fresh set of gaskets, and should be all good. That's the condition of the cams and the saddles that came out of the munched engine. Doesn't really look too good. These are the crow springs. Utilize them. This is the sump from the gas engine. Upon removing it, I dropped it off the engine stand and it cracked, but I've got another one ready to go. Alright, so I got the oil pump disassembled and I have thrown in the gear set just in there for now. It's all dry. Just doing a few checks before I send it. I'm going to put a straight edge across the housing there and see if the gears spin freely. Make sure it's not snagging on anything. Seems to be good. Now I want to check the clearance of the gears to the housing where the backing plate will bolt onto. I'm aiming for around 3 thou from the research I've seen. So we'll have my feeler gauge here. This is 2. Goes in, no worries. 3. Goes in, and it's just starting to show some resistance. Grab the 4. 4 doesn't go in at all. It's pretty good. 3 thou clearance. Next, I want to check the tip-to-tip clearance. So have the gear sort of sitting down up against that section. See what we come up with. So we'll start off with 3. No worries. 4. Yeah, that goes in. Let's hit it with a 5. Yep, 5. 6 to 8. That is it, right. Well, these things happen. I've returned those oil pump gears back to where they came from and instead opted for a new set of Australian made, Australian machined oil pump gears. Hopefully these tolerances, and I'm going to be checking them, are a little bit better in spec, because running nearly 1 millimeter of clearance between tip to tip, I'd have assumed I would have run into oil pressure problems and all sorts. So once again, I've got my oil pump housing clean. Support local businesses when you can. And these look actually quite nice. Bit slippery. First check, straight edge, see if we spin. All right, that is 1.5 thou or 0.004 millimeters. 2 thou goes in, but it's showing some resistance. And I think 3 thou. Three thou goes in, a little bit of resistance as well. 5 thou doesn't, so 4 thou clearance on the straight edge and the top of the gears from the housing face. That's pretty good. Now let's check the clearance of the outer gear and the housing that it sits in. Okay, let's check the clearance from tip to tip. So make sure that the bottom cog, or the inner cog, is sitting right up against the outer cog down the bottom, and I'm going to check the opposite. So while I've got the 5 thou feeler gauge out, that goes in, 6 thou. So we got about 9 thou clearance, which is much better than, which is 0.23 millimeters, which is much better than the other ones were. So I'm happy to run them. 12 newton meters. And 15 for the pressure relief valve. Here I'm doing a very detailed analysis of which end of the spring is wider. The wider end will allow more of my finger to reach up into it. The top retainer sits on the narrow end of these conical springs, and the wider end sits on the head bosses. This is a special Barra valve spring removal and installation tool. I need to pressurize the cylinder I'm working on because once I remove the springs, I'm also replacing the valve stem seals. Most of the time the valve stem seal does a good enough job of holding valves up, but once I remove the old ones, the valves are going to want to drop down. To put air into the system, all I had lying around that had the right spark plug thread was a cheapy compression tester hose. I had to drill out the ball valve though, because unlike a compression tester where it's pushing air from the combustion chamber out to the gauge, I need to push air into the combustion chamber. This renders the hose and this particular compression tester kit useless, but handy for this job. Okay, here's the Barra ready to drop in. I'm waiting for a new heavy duty clutch because this one has been fairly used. Some spots where the rivets are, there's a bit of meat left, some spots there isn't, so just to be safe, I've got a new heavy duty clutch on its way here. When the clutch was done last time, I had this extreme flywheel installed. I'm pretty sure you can actually buy, when you buy the clutch kit, the first one that comes up for a heavy duty one has the flywheel included. I've purchased the pressure plate, clutch kit, spigot bearing and everything like that without the flywheel, because this flywheel is still pretty good. I'll give it a little bit of an emery cleanup. Of course I've got some new flywheel bolts, and that is a new pilot bearing. I thought I could reuse the other clutch, but changed my mind in the last minute. Engine mounts are on, heater hoses are on, the turbo manifold's installed. I've used high tensile grub screws with wedge lock washers. They've all been torqued to spec. As you can see, the braided oil line from Golby's parts has been installed. This isn't the turbo that came off the car. That's actually here because it needs new cords, had it. So this is a GT3582R. It was off an FG, I believe. Actually it was off an FG F6. So I had to reclock it. And that's all sitting in there nicely. It already came, it's a second-hand unit, but previous owner upgraded to a newer one for more power, and this one already had the Turbo Smart actuator there. The intake manifold and wiring and map sensor and fuel pressure regulator were all off the original turbo. I just swapped them over, new gaskets, torqued it down to spec. Of course the rocker cover is from the original. I'm not running the green top. The loom has all been installed. I've had to do a repair here. Mainly because on the exhaust cam sensor, the original wires here were all sort of peeled back and exposed, so I cut one off a rec and soldered it on. I have to do the same with the regulator plug. This one I cut off a rec. The same issue with the old one. It was all exposed here, so I actually found one in good condition at U-Pull-It, cut it off, and I'll be fixing that once I get to the car. The engine bay has been cleaned up. I've got brand new engine mounts installed. Best to do it now. And the new clutch kit comes with a concentric slave as well. So I'm just going to wait for the clutch and get this engine in the car. Well, the engine's in, and man, did I struggle for 3 to 4 hours. In hindsight, I should have just removed the gearbox, and that way I could have got it in, had it at the right angle, and it'll drop straight in. But no, the gearbox needed to be at a certain angle, and I had to try and get the engine to, you know, meet up with the gearbox and the input shaft and all that sort of stuff. So that was a bit tricky. The engine mount brackets were on the engine, but the engine mounts itself were bolted to the cross member. So when the engine was halfway in the engine bay, I had to remove the engine mounts from the cross member, try and bolt it up to the engine mount brackets on the block, and then I was able to sit them in, and you could put the bolts straight in easy after that. And the fact that the engine itself is like 800 mil lengthwise, which is actually from this point of the radiator support to that firewall place, that firewall area, it actually won't drop straight down. I think maybe the later models, FGs and that, you can, but this model you can't. So, you know, it had to be at a certain nearly horizontal, but then I found out by turning the engine so the front was here and it was sort of diagonally, you could drop it in and sort of turn it straight. And yeah, so a bit of a struggle. So now I've got to put all the bell housing bolts on. I've got the heater hoses to connect, the air conditioning compressor back on the block. That's not too bad. I've got to buy a new alternator because the old one is crap. The power steering system back on the block. Plumb up the turbo. The vacuum hoses. A couple of plugs to do. Those two near the ECU. And then start really putting it all back together. Serpentine belt as well. And bleed the clutch. So yeah, quite a few more things to do, but the hard part's done now. Well, I'm going to leave this video here. It's getting long enough, and yeah, I've got a few boring things left to do here to get the engine in a position where it's ready to be started. So fluids, a few more plumbing up of vacuum hoses, and you know, fixing some wiring here and there. And yeah, hopefully next time we see this car, it should be ready for its first start since the replacement motor. Thank you very much for tuning in, and we'll see you in the next one. Cheers. See ya.